The purpose was to determine the amount of energy found in the calorie content of certain foods by using the concept of calorimetry. The calorie content of foods will also be determined by observing the changes of heat in a system. If the calorie content on the label is accurate, then our results will match that of the label. The transfer and conversion of energy can be understood with the law of conservation of energy. This concept states that the loss of energy from one body will be gained by another. Heat is the transfer of energy between the differentially tempered bodies. The principle that the hotter object will transfer heat to the colder object is the basis for calorimetry. The required heat can be calculated with the formula for heat. Q is equal to m times c times triangle T. It's important to know as Q is equal to heat energy, m is equal to the mass of the object, c is equal to the specific heat, and triangle T is the difference between the final heat and the initial heat, also known as the change in temperature. The conversion between calories and joules must be understood too. 4.18 joules is equivalent to 1 calorie, and 1 kcal is 1,000 times more than 1 calorie, just the same as 1 kilojoule is equal to 1,000 joules. The following materials were needed for this lab: Cheeto Puffs, marshmallows, lemon lays, a soda can with 50 grams of water, a wooden stick, a metal ring, a cork with a pin in it, also used as the food holder, and a thermometer. In order to do this lab, take one food object and place the pin through it. Measure the mass of the cork, also known as the holder, and record the combined mass of the food sample and the holder. The holder with the food should then be placed at the base of the stand. Add 50 milliliters of water to the soda can. Elevate the can with the wooden stick and the metal ring about 2.5 centimeters above the base. The thermometer will then be placed into the can's water and should be suspended by a string so that the thermometer is not touching the base of the can. Then measure and record the initial temperature of the water. Once you ignite the food sample, then place it under the base. Use this flame to heat the bottom of the can until the entirety of the food has been burned. Record the final temperature of the water and the final mass of the burned food sample, and finally repeat this process with the other two samples.
Before interpreting the results and data, the physical observations can be acknowledged. In regards to the samples, the Cheeto Puffs burned the brightest and for the longest period, which contrasted with the marshmallow's refusal to ignite. Lemon lays can be considered the middle ground, but when burned, the most potent of smells was emitted. Now various sets was recorded throughout the lab, starting with the Cheeto Puff sample, initially recorded at 3.6 grams in 29 degrees Celsius water. The process of burning burned off 2 grams, leaving 1.6 grams and a final temp of 69 degrees Celsius water. Given this information, the calories can be calculated as 2,000 calories or 2 kcal, which represents 1 kcal over grams. Moreover, per serving, in comparison to the given values on the sample nutritional chart, the values are similar but not the same. 6 kcal serving to 6.15 kcal serving. Marshmallows next. Beginning at 8.5 grams in 30 degrees water, the lab resulted in a final mass of 7.9 grams, and 0.6 grams were burned off, and a water temp of 33 degrees Celsius. The given information can be calculated to find the energy of 115 calories or 0.15 kcal with an energy content of 0.25 kcal per gram. The energy content per serving is close but noticeably not the same. 1.25 kcal serving to 3 kcal servings. The final sample, lemon lace, began at 2 grams in 21 degrees Celsius water, only to burn off 1.2 grams and end at 0.8 grams in 36 degree water. The energy of the sample was recorded at 750 cal or 0.75 kcal and an energy content of 0.625 calorie grams. The sample also has a similar energy content per serving between the calculated and given values, 9.375 kcal serving to 5.36 kcal grams per serving. The calorie content of the label cannot be accurate because our results were not equivalent to that of the label. Each sample produced different results that depicted the unique energy content and heat energy of that sample. The Cheeto sample proved to be the most dramatic test as it burned the brightest and for the longest time, yet lost the most mass. It also proved to have the greatest calorie content, having 1 kilocalorie per gram. The marshmallow refused to ignite and And though what we were able to burn, we found that it had a calorie content of 150 calories per gram. Lastly, there were luckily no issues with the lemonade, which had 625 calories per gram.
Each test was done following the same procedure, yet provided unique results. The results themselves provide the answer to the question on the calorie content of the sample and the energy content of the system. The recorded data on the sample voices look into how much mass was removed by burning the sample, how much thermal energy is produced by the burning sample. This information will then be applied when observing the energy content of the system. In that, the thermal energy produced will be transferred into energy content absorbed by the system. For most produced energy to least produced energy, the samples order Cheeto Puffs, lemon lace, and then marshmallows. This order is consistent with the calorie content and the produced energy content. Possible errors would have been the place the flame was in contact with the can. This can be solved by placing the flame on a designated spot on the base and protected from any outside forces such as a breeze. Another possible error would be the temperature raising after the first food product was burned. The water may have increased from its original temperature, then from the temperature it was left at. A solution to this would be to let the water cool down to its original temperature.